In this movie, we will focus on gunshot residue examinations that are involved in the forensic sciences. In forensic cases where guns are involved, it may be important to confirm that a weapon was fired, by whom, and the distance of the barrel to the bullet hole. Gunshot residue examinations are performed with inexpensive presumptive color tests that can determine the presence of some elements comprising ammunition. An examiner would expect to find gunshot residue around the bullet wound, on the suspect, and on any nearby surfaces upon firing of the weapon. Before we talk about the color test, let's talk about the components of ammunition. A cartridge and a shotgun shell consist of similar parts. They both have projectiles, a propellant or gunpowder, a primer, and a rim. Shotgun shell also contains a wad that separates the propellant from the projectiles or the shot. The brass head in the shotgun shell and the casings hold all of these components together. Gunshot residue consists of particles from nearly all of these components of ammunition. The primer contains a mixture of lead cyphnate, antimony sulfide, and barium nitrate. When a weapon is fired, the firing pin strikes the primer, initiating a chemical reaction that ignites the gunpowder, which is composed of nitrates from either or both of nitrocellulose and nitroglycerin. As the bullet is expelled, these particles from the primer and gunpowder are discharged. This discharge, along with soot, is expelled onto nearby surfaces such as the hand of this individual. Also, in the case where bullets are copper-coated, some copper particles may be left behind as well. The presumptive color tests for gunshot residue are very simple to perform once the various solutions and reagents have been prepared. The Harrison-Gilroy test is employed to determine the presence of antimony. The sodium rhodozonate test is for barium and lead. The modified grease and diphenylamine tests are for nitrates, and the dithioxamide test is for copper. After preparing the corresponding reagents and solutions for each, the gunshot residue examinations can be performed on the unknowns alongside controls to ensure that the reagents are working properly. The Harrison-Gilroy test for antimony was performed on an unknown deposit on a t-shirt. A sample was tested with the diphenyl methylarsodium iodide solution. An orange color change will appear if the antimony ion is present. With the controls, we can see that the reagent was working as intended. The sodium rhodozonate test for barium and lead was performed on an unknown deposit on a t-shirt. A sample of the t-shirt was saturated with the sodium rhodozonate solution. An examiner would expect to see a yellowish-orange color. When the buffer solution is added, the sample should turn pink, indicating the presence of lead, and reddish-brown for barium. If hydrochloric acid is added, the color should change to a deep violet blue for lead and bright red for barium. The modified grease test for nitrates was tested on an unknown deposit with both grease reagents A and B. A bright orangish red color is expected if nitrates are present. The diphenylamine test is also for nitrates, but a positive indication results in a dark bluish purple color. The dithioxamide test is for the presence of copper, which will produce a green color as a positive indication. This concludes the presumptive color test for gunshot residue examinations. We have looked at the components of ammunition and gunshot residue, as well as what color changes to expect from these presumptive tests for gunshot residue. The procedures on how to prepare the reagents used in these tests can be found in Practical Forensic Microscopy by Barbara Wheeler and Lori Wilson.